Recording. Okay. Good morning, students. Okay, I hope all of you are doing fine and doing well. Okay. So this will be the second online class, and today altogether 126 students enrolled, out of which 83 students are coming live now. 84, still increasing. Okay, so there is some improvement. Okay, since yesterday. All right then, let's not waste any time, and then we shall continue with the discussion. So before we start the class, I want all of you to be ready with your textbooks, okay? Your notebooks for noting down the things that I am working on. And then you must be with your textbook because I have no time in the board. The space of the board is very limited, so I cannot keep on writing down all the questions. We have to keep enough space for the solution. So I want every one of you to be with your textbooks and notebooks, okay? Okay. All right then. So let's turn to NCERT textbook, chapter 9, applications of trigonometry. Yesterday we worked out up to question number 4. Today we'll be starting up with question number 5. There is just one information, just another reminder. Yesterday I have told you the same thing. Today I'm repeating it again. Since our syllabus is so vast that even though we try to rush, we will not be able to finish the syllabus in time. So I won't be able to cover all the syllabus in this live class. So what I have done is I have uploaded some videos on some chapters. Since last week up to this week, I have been uploading for chapter 4 quadratic equations in YouTube, and I am sending you the link. I've been sending you the link through WhatsApp, but it seems that you are not interested to look on those videos. But those videos are not meant for anyone, but only for you students. So if you are not going to make use of those videos to learn, then when are you going to learn? And we do not know when are we going to have our offline classes. No one can predict that. And online classes, since we are all of us are having very tight schedule, okay, we cannot extend our classes for several hours in a day. So since our time is very limited, so what I want you to do is the chapters that I have uploaded in YouTube, I think you need to like go through those things and make a note of it. Okay, you need to make a or maintain a proper notes on all the videos that have been uploaded. And on the live class, we will be doing the chapters which we have not done. Is it all right? And very soon you're going to have your weekly tests and so you need to prepare yourselves for that. Okay, so just this a small reminder that I want to share to you. Are you able to hear me? If you are clear with the things, you can please comment on the chat that we can start. Okay. 92 students are live. 92 students are live. Okay, no one is commenting. Okay, okay, all right, all right. Okay, then let's start. Okay, who is this idiot tree? Ah, yeah. Please, you see, there is one boy or girl I do not know whose name is idiot tree. And then, how am I going to give you attendance using that name? Okay. Idiot tree. Please use your original name. Use your original name so that attendance can be given according to that. All right. Okay. So we'll go for question number 5 now. As I read the question, I also want you to look at your textbook. Okay. So we'll try to understand together what is given exactly. So your question number 5 says, a kite is flying at a height of 60 meters above the ground. So the kite is flying at a height of 60 meters above the ground. Okay. The string attached to the kite is tied to a point on the ground, just for temporary. Okay. The string attached to a kite is tied to a point on the ground. Angle made by the string, inclination means angle. The inclination of the string means angle made by the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. That means there should be no slack, means uh, the thread, okay, should be so tight. The thread connecting the kite and to a point on the ground should be stretched so tight. Is it okay? Yes. So let's say that A is the position where the kite is flying. A is the position where the kite is flying. This is your ground level. Let's say that this is your ground level. This is the ground, okay? Here A is the position where the kite is flying. Okay. So the kite is flying at the height of 60 meters above the ground. So the height of the kite is 60 meters above the ground. And height should always be measured in perpendicular distance. Okay. Suppose you are asked to find out the distance between two places. I think today there is some network issues, but okay, let's all cooperate. So, the string makes an angle of 60 degrees with the ground. So using this information, we need to find out the length of the string. Using this information, we need to determine the length of the string. Here AC represents the length of the string. If you have any network issues, are not able to visualize the video properly, then there is always a recording which will be available on the class that we have taken within 24 hours, okay? Before that, it will not be available. So you can just check on the recordings also if you have missed, okay, due to the class, due to some network issues. So this is how we have drawn the figure according to the question. And we need to determine the length of the string, which is your AC, okay? So what I'm going to write is, let AC be the length of the string. The length of the string. This is our objective. Okay? This is our mission, to find out AC. Now, this is a right triangle. This is your angle theta. All right. Here, the side, this is the side, AB is the side which is opposite to your angle theta. Theta is given to be 60 degrees, right? So AB is the side opposite to your angle theta, which is given, and we want to find out the hypotenuse AC. That means here BC is not required. BC is not required here. Okay, the adjacent side is of no use now. So in this right triangle, opposite side is given, and we want to find out the hypotenuse. So altogether there are 6 trigonometric ratios. So out of the 6 trigonometric ratios, you need to choose a trigonometric ratio which involves the opposite side and the hypotenuse. Okay? So a trigonometric ratio involving the opposite side and the hypotenuse is either sine theta or cosec theta. So you can use any one of these trigonometric ratio. Alright? Yes. Depending on which side is given and which side we want to find out, we have to choose the trigonometric ratio accordingly. Alright, class? Yes. So, in right triangle ABC, okay, we are going to choose a trigonometric ratio which involves the opposite side and the hypotenuse. So in right triangle ABC, sine theta will be given by side opposite to angle theta, that is AB, upon the hypotenuse AC. But it's clearly given that the angle theta is 60 degrees. So theta has to be replaced by 60 degrees. So the value of sine 60 degrees is square root of 3 upon 2. AB, the length of AB is 60 meters. AC is what we need to determine. All right. Now, if you cross multiply, square root of 3 times AC would be equal to 62 times is 120 meters. In that case, your AC would be 120 upon square root of 3. So we have determined AC. But is this our final answer? No. Yet last class also I have told you that in the denominator, there should be no term in square roots. Okay? To do, we need to rationalize the denominator in order to get a more precise answer. Okay? Yes. So what we need to do is, let us rationalize the denominator. 120 upon square root of 3. If we rationalize the denominator, then on the denominator we need to multiply by square root of 3. And on the denominator again, we need to multiply by square root of 3. Alright? Yes. So your AC will now become, okay, 120 times square root of 3 upon square root of 3 times square root of 3. 340 times is 120. So your AC is 40 square root of 3 meters. That means the length of the string is 40 square root of 3. Alright? So that gives you the complete answer. So question number 5 is done. So you can please note it down. If once you are done, you can please comment on the chat that you are done. Okay? so that we can proceed on with the next question. If you are done copying it down, please comment on the chat that you are done, and we can start proceed with the next question. Okay, all right. So we go for the next question. That is question number 6. Okay. So let's look at the question together. Okay, as I read the question, okay, you need to look at your textbook. All right. So let's proceed. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. Okay. So let us study the question part by part. Accordingly, we are going to draw the figure. Okay. So a 1.5 meter tall boy. So this is 1.5 meter tall boy. So let's say that AB is the boy. AB is the boy who is 1.5 meters tall. AB is the boy and he is 1.5 meters tall. What is he doing? He is standing opposite to a building which is 30 meters tall. Okay, the boy is standing at some distance from the building which is 30 meters tall. So this is the building. Let's say that this is the building. So CD is the building. CD is the building. That means C is the foot of the building. D is the top of the building. So this boy is standing at some distance from the building. The height of the building is given to be 60 meters. 30 meters, 30 meters. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Now, okay, let us try to understand this part. This is the boy. What is he doing? He is looking up at the top of the building. This boy is looking up at the top of the building. So yesterday I have taught you the concept of angle of elevation and angle of depression. So we're going to use that concept over here. This is the boy and he is looking up at the top of the building. Okay, so yesterday we have learned that from the eye of the observer, you always draw a straight line which will be parallel to the surface of the ground. Let me give the name of this line to be AE. Okay, AE. Yesterday we have learned that from the eye of the observer, you always draw a straight line which is parallel to the surface of the ground. That line would be known as the horizontal line. Now, you draw another line connecting the eye of the observer to the point where he is looking. He is looking at the top of the building. So you need to draw another line connecting the observer eye and the top of the building. Is it okay? Now, there is an angle formed. In between the horizontal line and the line of sight. This angle formed will be the angle of elevation. So in the first case, when the boy was standing at this position, the angle of elevation formed is 30 degrees. The angle of elevation is 30 degrees. Means angle between the horizontal line and the line of sight is 30 degrees. All right. Now, as this boy walks towards the building, his angle of elevation increases from 30 to 60 degrees. The angle of elevation increases from 30 to 60 degrees as he walked towards the building. That means at first when he was at this position, the angle of elevation is 30 degrees. Now as the boy moves towards the building and reaches this position, when the boy reaches this position, all right, then suppose, let me say this point is your A dash, this point is your B dash, all right? When the boy reaches this position, and then when he looks up at the top of the tower, in that case, the angle of elevation now becomes equal to 60 degrees. Is it okay? Yes. We are going to find the distance he walked towards the building. The boy was at this position first, at AB position. He walked towards the building, and now A dash B dash is the final position. So we need to find out what is the distance the boy walked. So this is the distance the boy walked, or this is the distance the boy walked. So A dash is the distance the boy has walked. Is it okay? Yes. So let A dash, or you can take it to be B dash. Same A dash, B dash is same thing. Is it okay? Yes. Distance between two points, you can measure it from head to head, or you can measure it from feet to feet. Is it okay? Both the lengths will be equal. Are you following me? Yes. So here A dash is the distance the boy walked. So let A dash be the distance the boy walked. Now let's see. This is the right triangle. We can see two right triangles here. Okay, we can see there are two right triangles. One is your dash DE. This is the smaller one. One is your A dash DE. This is your first right triangle. There is another right triangle which is AED. So there are two right triangles. One is A dash ED and one is AED. For this smaller right triangle, the angle theta will be 60 degrees. And for the bigger right triangle, the angle theta is 30 degrees. Okay, that is what we have to take. Now you see, class, if AB is 1.5 meters, then CE also will be 1.5 meters. Why? Because opposite sides of a rectangle are equal. Opposite sides of a rectangle are equal. Okay? So if AB is 1.5 meter, then CE also will be 1.5 meter because opposite sides of a rectangle are equal. So AB would be equal to CE is equal to 1.5 meters. Why? Because they are the opposite sides of a rectangle. Opposite sides of a rectangle. So many are sending to join requests. Okay, sending requests to join, but I cannot. Okay, because we have already started with the video, and if I keep on accepting all those invitations, then our class will be spoiled. Okay, so let me not accept any more invitations. We have 98 students coming live now. Okay, 99 now, 100. Okay. Now AB and CE are equal because they are the opposite sides of a rectangle, so it's 1.5 meters. Now you see here, very important, the length CD. The length CD is 30 meters. So from this 30 meter, from this total length 30 meters, then it will give us the length of this part, DE. Correct? Let me repeat. CD is 30 meters, right? So from this 30 meters, if you subtract this 1.5 meter height, then the remaining height DE, okay, will be obtained. That means DE can be written as from the total length, from the total height CD, if we subtract CE. From this total height CD, if we subtract CD, then we get the remaining height DE. So CD is 30 meter minus CE is 1.5 meter. So 30 meter minus 1.5 meter, 28.5 meters. So this DE is 28.5 meter. That's the length of this DE. That's the length of this DE. Now, what is our objective? Our objective is to find AA dash. Our objective is to find AA dash. So the question is, how are you going to find out this AA dash? Very simple. This is your AA dash. So AA dash can be obtained. How? How are you going to obtain this AA dash? AA dash, this is your AA dash. This length is your AA dash. A dash is not here to you, so yeah. This length is your AA dash. We can obtain AA dash by subtracting AE and A dash E. From this AE, from this full length AE, from this full length AE, from the full length AE, if we subtract A dash E, if we subtract A dash E, then we obtain AA dash, which is our objective. All right? So first of all, let us find out what is AE, and we're going to find out what is A dash E. If we subtract them, we get AA dash. Are you clear? AE. Let's find AE. Then which right triangle are you going to choose in order to find out AE? The bigger right triangle. The bigger right triangle, AED. In the bigger right triangle, AED, let me draw the bigger right triangle. This is your bigger right triangle, A. This is your E. This is your B. Angle is 30 degree, right? Okay. And then DE is 28.5 meter. So from this right triangle, I'm going to find out AE. For this right triangle, we want to find out AE, and AE is the side opposite to your angle theta here, right? Here theta is 30. So AE is the side opposite to your angle theta. And what is given? No. AE is the side adjacent to your angle theta, not opposite. From the bigger right triangle, we are going to find out AE, and AE is the side adjacent to your angle theta. Can you see me? Can you see this? Okay, yes. All right. Okay, thank you, students. So where were we? Okay. In order to obtain AA dash, okay, we need AE and we need A dash E. I think that part is clear, right? Now, how are we going to find out AE? How? We choose the bigger right triangle. This is where I have drawn. I've drawn a bigger right triangle separately. AE is the adjacent side to angle theta. B is the opposite side. Opposite side is given and we want AE adjacent side. So we have to take a trigonometric ratio which involves the opposite side and the adjacent side. So that is either tan theta or cot theta. Okay? All right? Yes. So in right triangle AED, your angle theta. So tan theta is equal to side opposite to angle theta, that is DE, upon side adjacent to angle theta, that is AE. Okay, let me remove this now. Now theta is given to be 30 degrees, so I'm going to replace theta by 30 degree. Then 30 degree means 1 upon square root of 3. DE, what is your DE? It's given, DE is 28.5 meter. I've obtained right here DE. No need to search in the figure. DE is 28.5 meter. Upon AE, that is what we are going to determine. If you cross multiply, AE will be 28.5 square root of 3 meters. 28.5 times square root of 3 meters. So this is done. This is done. AE is done. Now we want to find out A dash E. This is the particular right triangle where you have A dash E. So let me draw that small part of the triangle. This is A dash E, and this is your D. DE is 28.5 meter. This angle theta is given to be 60 degree. Okay. So here also, in this right triangle, in order to determine A dash E is your adjacent side, D is your opposite side. So we take the same trigonometric ratio, tan 30 degree, or tan theta. We take the same trigonometric ratio, tan theta. So again, in right triangle A dash ED, tan theta is equal to side opposite to angle theta DE upon side adjacent to angle theta, that is AE. Theta has to be replaced by 60 degrees. Then 60 means root 3. DE is 28.5 meters upon AE. Correct? I mean A dash E, A dash E, A dash E. Adjacent side is A dash E. So if you cross multiply, root 3 times A dash E is equal to 28.5 meters. So your A dash E will be 28.5 upon square root of 3 meters. Is it all right? Is it all right? Yes. Now we have obtained AE, we have obtained A dash E. Now let us determine what is this AA dash. Therefore, finally, AA dash will be AE minus A dash E. I've shown you this, right? Your AA dash will be given by this full length AE minus A dash E. That gives you this. Okay? So AE, your AE is 28.5 square root of 3 meters. Okay? Minus A dash E is 28.5 upon square root of 3 meters. What can we do here? What can we do here? We can take 28.5 in common. We can take 28.5 common. So if we take 28.5 common, then from this term we have root 3 minus from this term we will have 1 upon square root of 3 and then. But that's not the final answer here. Textbook may have given in this way, but we need to simplify. We need to simplify this particular term. Okay, only then we will get a very precise answer. So in order to simplify that, please mute off. Please, please mute your videos. Okay, because see, Sangchingla, I think you are disturbing. I'm not able to take proper class. Okay, you please mute. Okay, yes. All right then. So in order to simplify this one, we need more space. So I need to rub out this part. Okay, is it okay if I rub out this part? Is it done with you? Is it done? Are you done copying this part? All right, so if this part is done, I'm just going to remove this slightly. Okay, I'm just going to remove this. So we will have more space for further evaluation. That means your AA dash will be 28.5. And then let's simplify this. What is the LCM? LCM of 1 and square root of 3 will be square root of 3. Okay? LCM of 1 and square root of 3 will be square root of 3. Since the first denominator is 1, LCM will simply multiply the numerator. If the denominator is 1, LCM will simply multiply the numerator, right? So square root of 3 times square root of 3 is 3. Here LCM is square root of 3. Second denominator is also square root of 3. So they will cancel out each other. So we have 1 in the numerator. Just taking LCM. Everyone knows how to take LCM. Okay. So 28.5 and then 3 minus 1. 3 minus 1, 2 upon square root of 3 meters. Let's multiply. 2 5 times is 10. 2 8 times is 16, 17. 2 2 times is 4, 5. After 0.1 digit, so 57.0. But 0.0 can be neglected. So we have upon square root of 3 meters. This is not the final answer because denominator should never contain square root. So what we need to do, we simply need to rationalize the denominator. We simply need to rationalize the denominator. 57 by square root of 3 into square root of 3 upon square root of 3. So 57 times square root of 3 upon square root of 3 times square root of 3, 3. 3, 1, 3, 3, 9 times is 27. So the distance the boy walked towards the building, AA dash. A dash is the distance the boy walked towards the building, and this is the required distance. This is the required distance. So which completes our answer. Okay, so you can just copy it down. If it is done, if you are done copying, you can just let me know. There is some unnecessary chats going on in between the students, and I'm not appreciating that. Okay, only when I ask you to comment, only then you can chat. You can comment on the chat. Okay, otherwise students are not allowed to chat between yourselves. Okay, when we are going live, if you want to have interactions, you can WhatsApp to your friends personally, not through this chat. Okay, whenever I ask you, only then you are supposed to comment on the chat. Otherwise, you are not permitted to do so. You are not permitted to do so. So if this question is done, then we can proceed with the next question. That is question number 7. So if this is done, let's go for question number 7 now. So we move on to question number 7. As I read the textbook, I want you to go through your textbook at the same time, so things becomes easier for us. All right. Yeah. From a point on the ground, the angle of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. That's the question. Okay, let's read it again. Let's try to understand the given situation here. From a point on the ground, means observer is just a point on the ground, like an ant. Okay, if you keep an ant on the ground, then ant is just like a point of light. Yes, very small. So from a point on the ground, means observer is on the ground, a very small observer. The angle of elevation means looking up. Okay, so you are looking up. Where are you looking up? Bottom and top of a transmission tower. So from the ground, you are looking up at the top of the transmission tower and then to the bottom of the transmission tower. But where is this transmission tower? Let's see. Transmission tower is fixed at the top of a 20-meter high building. So the tower that you are looking up at the top, you are looking up at the bottom of the tower, right? And this tower is fixed at the top of the building, 20-meter high building, okay? And you want to find out the height of that transmission tower. Tower is fixed at the top of the building. So this is question number 7, question number 7. So this is your building. AB is your building. Building is 20 meters high. Okay, building is 20 meters high. Where is the transmission tower? At the top of the building. So at the top of the building, a transmission tower is fixed. Okay, so this is your transmission tower. So AC is your transmission tower, and this AC is fixed at the top of the building. Building is 20 meter high. Where is the observer? Where is the observer? On the ground. Observer is on the ground. Observer here. Observer is on the ground. Okay. So from the eye of the observer, you always draw a straight line parallel to the ground, horizontal line, right? Horizontal line. What is this observer doing? What is this observer doing? He is looking at the bottom first and then top of the tower. This observer, he is looking at the bottom first and then top of the tower. So this observer, he is looking at the bottom of the tower. See, this observer is looking at the bottom of the tower. So this is the line of sight. This is the horizontal line. Angle between them is angle of elevation, which is 45 degree. Okay? Again, the same observer, after looking down, he's looking up now at the top of the transmission tower. So the same observer is also looking up at the top of the transmission tower. The same observer is again looking up at the top of the transmission tower. Okay, so this time here, this is your horizontal line, this is the line of sight now. So this big angle is given to be 60 degrees. This big angle, no? Angle between the horizontal line and the line of sight. This bigger angle is given to be 60 degrees. All right, class. Okay. Our aim, find the height of the transmission tower. Which is the transmission tower? Which is the transmission tower here? AC is the transmission tower. Okay. So the height of this transmission tower is what we have to determine. So let AC be the height of the transmission tower. Let AC be the height of the transmission tower. That is our objective. Now, but how do we find this AC? How are we going to find this AC? Very simple. In order to obtain AC, what we have to do is, from this total height, BC, right? From this total height BC, we need to subtract the building AB. Then we get AC. Are you getting me? Is the things clear? Okay. From this total height BC, we will subtract the height of the building. Is it all right? Then we get the transmission tower. Now, BC is already known to you. BC is already known to you. So, find out the is is